Hello students, welcome back to my channel again. Today we are going to learn class 11's probability chapters and this is the fourth session. So previous three sessions, if you want to watch, you can come to my channel again and just search for it. You will be getting all other three sessions. So let's start with today's lesson. And today we are going to learn axiomatic approach to probability. Now before we start axiomatic approach to probability, I just want to give some introduction to it. So in our day-to-day life, we normally use many words of chances of occurrence of events. Now probability theory attempts these chances of occurrence or non-occurrence of events. Already, some methods for assigning probability to an event associated to an experiment having known the number of total outcomes. Axiomatic approach is another way. Here, some axioms or rules are depicted to assign the probability. And this is the difference. So let's start with axiomatic approach. Now let S be the sample space of a random experiment. We are actually taking P as real valued function whose domain is the power set of S, the sample space, and range is the closed interval 0, 1, satisfying the following axioms or rules. That is, for any event E will be P of E greater or equals to 0, P of S will be equals to 1, and if there are two events and they are mutually exclusive events, then P of E union F will be P of E plus P of F. But for this, we need to have two mutually exclusive events. Now, if F equals to phi, then what will happen? F equals to phi means E union F equals to E union phi, that is equals to E. And P of E union phi, just we have learned that if these two are mutually exclusive, that means these two will be disjoint sets, then this will happen. P of E plus P of phi, individually addition of these two functions. Now P of E, this one will be P of E because E union phi is equals to E. So it is P of E equals to P of E plus P of phi. That implies P of phi equals to 0. Now look, I have given somewhere this type of highlighted parts, and these are very important parts for this lesson. Now one thing, students, in this session you will learn another more thing, that till today, means till class 10, the way we have found probability of some event or something, how that came here. So axiomatic definition of probability will give us that concept also. Now coming to axiomatic definition of probability, and that implies 0 less equals to P of A1 less equals to 1 for any A1 belongs to S. Now S is the sample space containing these n number of elements A1, A2, An. Now look, here we are just neglecting this second bracket, set bracket. Actually we should write like this, but we are just writing, in spite of this one, we are writing P of A1 directly. Now these are actually elementary events. We call it as elementary events. Okay, singleton sets events, we call it as simple events or elementary events. Now elementary events probability, we can write it like this without this second bracket. So let's come to this. That means What does it mean? It means any probability we will be getting the value between 0 and 1. It can't be negative. It can't be more than 1. The second condition tells that P of A1, if it satisfies that S equals to A1, A2 up to AN, then P of A1 plus P of A2 plus dot 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 plus P of AN will be equals to 1. That means individually addition of all probabilities of all elementary events will give us the result 1, because this is the sample space. Third condition, for any event A, from this just we can write one thing, that we know P of S equals to 1, right? Here we have told once P of S equals to 1, and here P of S equals to 1. That means P of A1 plus P of A2 plus dot 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 P of AN equals to P of S we can write. So we are just taking that any event A, and A suppose are having the elements omega 1, omega 2, omega 3 and dot dot dot. So P of A will be addition of probabilities of all sample points or all elementary events in that particular event. Now for example, suppose we are tossing a coin, then what normally we get? We get P of head. That means P of head we are taking, okay? We are not telling that probability. P of head equals to half, P of tail equals to half. Now for these two we are just taking this number one assignment. This number one assignment has been given. P of H equals to half, P of T equals to half. This is given. We are not finding it now. This is given. So 0 less equals to P of H less equals to 1. It is valid. 0 less equals to P of T less equals to 1. It is also valid. Another thing, P of H plus P of T equals to half plus half equals to 1. So what we can say? We can say that for H and T, these two conditions are satisfied. As these two conditions are satisfied, then we can say that probability of H equals to half and probability of tail equals to half. Now, suppose we are taking P of H equals to 1 by 4 and P of T equals to 3 by 4. And this is the given second assignment. Look, our natural convention is to get P of means probability of head is equals to half and probability of tail equals to half. But we are not taking it. We are doing here axiomatic approach to probability, which is little bit different. And we will come to our natural convention gradually. Before that, you need to understand this. Previously, P of H equals to half and P of T equals to half was the first assignment given, and now this is the second assignment given. For this second assignment also, these two conditions are satisfied. 0 less equals to P of H less equals to 1, 0 less equals to P of T less equals to 1, and their addition comes as 1. That means first two conditions are satisfied, so conditions are valid. That means we can say that probability of H equals to 1 by 4 and probability of T equals to 3 by 4. So both the assignments 1 and 2 are valid. They are valid assignments for probabilities. So in general, what we can say? So in general, we can assign any numbers P and 1 minus P to both the outcomes. We can assign any numbers P and 1 minus P, where P must be greater than 0, less than 1, 0 or 1. And 1 minus P will be obviously between 0 and 1. And P of H plus P of T will be P plus 1 minus P, that is equals to 1. So again I am repeating, in general we can assign any numbers to both the outcomes in this relation. Okay. In place of P, you can write any other alphabet that you want to use. So students, what we can conclude? We can conclude there are many infinite ways to assign probabilities to outcomes of an random experiment, and this is the main thing here to understand. Look at exercise 16.3's question number 1, and this is the assignments. These 5 assignments are given. Like we discussed some assignments, 2 assignments, here 5 assignments are given. We need to verify which assignments are valid. Now look at the first assignment. If you add these all, first we will look at this whether these are less than 1, greater than 0 or not. So there are no negative numbers and all are less equals to 1. That means first condition satisfied. Second condition, we will add this plus this plus this plus this plus this plus this plus this. If we are getting 1, then second condition is also satisfied. Obviously we will be getting here 1 after adding. So first and second condition is valid for A. That means assignment number A is valid. Assignment B is quite simple. It is valid because there are 7 sample points, 7 probabilities or 7 functional values. If you are adding, you will be getting 1 and all are positive, less than 1. So the assignment number B is also valid. Assignment number C, is it valid? No, this is not valid. The first condition is satisfied but not the second one. Because for the second one, the addition of all 7 numbers are coming more than 1. So assignment number C is invalid. Coming to assignment number D. Assignment number D, the first condition is not satisfied even, because we are having 2 negative numbers and it can't be negative. No element can't be negative here. So assignment number D is invalid. Assignment number E, up to this it is okay, but here we are getting 15 by 14. So this one is more than 1. Now more than 1 probability can't be there. So assignment E is invalid. Coming to the next point, probability of an event. Let 2 coins are tossed. What will be the sample space? You all know HH, HT, TH, TT. Now let E be the event where both tosses giving the same result. That means what? HH and TT. F be the event where exactly 2 heads come. Now these are the assignments given. Sample points HH, HT, TH, TT. Now probabilities are given like this: 1 by 4, 1 by 7, 2 by 7, 9 by 28. You can see from this that outcomes are not equally likely. So we are getting this even set like this, HHTT, and for F it is exactly 2 heads, that means HH. Now P of E will be P of HH plus P of TT equals to 1 by 4 plus 9 by 28 equals to 4 by 7. P of F equals to P of HH equals to 1 by 4 from the given assignment. Okay, so this is from given assignment. Now coming to probability of equally likely outcomes. And this is very important, my students, very important to know. Because if you can understand axiomatic approach to probability, I hope that the concept of probability will be automatically clear to you. So let us take that sample space S equals to A1, A2, comma dot 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 comma AN, where A1, A2, comma dot 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 comma AN are equally likely outcomes. What does it mean by equally likely? Equally likely means their probabilities, individual probabilities will be same, equal to each other. We are taking it as P, where obviously P will be from 0 to 1, anything. Now P of A1 plus P of A2 plus dot 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 P of AN equals to 1 because it is P of S. So P of S is equals to 1, that means it is equals to 1. Now all are having equally likely outcomes, so having same probability P, that means we can write N into P equals to 1. So we can write P equals to 1 by N. That means probability of all elementary events for equally likely outcomes will be 1 by N. Now let S be a sample space in general, I'm telling, and E be an event such that N of S equals to N, like this. And suppose E be an event such that N of E equals to M. Suppose M, obviously M less than or less equals to N. All outcomes are equally likely we are taking. Therefore, what we will write down? We will write down P of E equals to M by N. Why M by N? Because M elements we are taking here. One element's probability is 1 by N. So M elements probability will be M by N. Now what is M and what is N? You go back to your class 10's 9 and class 10's probabilities concept. You all know that probability of an event is number of favorable outcomes divided by number of possible outcomes. So number of favorable outcomes means number of elements in the event E, and number of possible outcomes means number of elements in the sample space. So my dear students, I hope everybody now understood that how did we get that classical approach to probability from this theory. I hope you all have got the clear idea up to this and there will be no confusion. So this is all about today's session, my students. In the next session, we will be doing many more other topics related to probability. Till then, bye-bye and thank you.